Okay, so we were finishing up this last one, and we noticed that the p's were the same, the bases were the same. So we're going to use the quotient rule to kind of simplify this last example. So we are going to take the denominator's exponent, which is the larger exponent, and that's going to stay down there. And then the smaller exponent is the 6. So that's what's going to be subtracted from the larger exponent, which means to say we need a place value of 1. So we're going to do p to the 23rd minus 6, which is going to give us 1 over 20 p to the 17th power. And that's our final answer. Okay? So it kind of like wraps up all of power rule. Okay, so right now I'm going to go all the way back to the top. So we've talked about product property, we've talked about quotient property, and we've talked about all the different kinds of ways to do the power property. So yeah, the only thing that we did not talk about is we did not do these problems, which I feel like now we can do a little bit, just a little bit easier, because we're combining a couple different things. So b to the 12th, we multiply these together, b to the, oh my goodness, the 12th. So that simplifies to 1. So it's nice and easy for us after all those complicated ones. And then again here, we're multiplying. So y to the 4 times 2, 8 over y to the 6th. And then we can use the quotient rule here because we have the same bases, and the largest exponent is in the numerator. So we're going to end up with y 8 minus 6, which is y to the 2nd power. And then the last one here, we kind of had already raised everything, or we have to now raise everything to the 4th. So this is couple different power rules here, and then we have 2 to the 4th power times m to the 2nd power, also raised to the 4th, and then we have 5 to the 4th power and n also raised to the 4th. So 2 to the 4th power, 2 times 2 is 4, 4 times 2 8, 8 times 2 is 16. And then we multiply 2 times 4, which is 8. And then we have 5 to the 4th power. And I'm not even going to pretend to be able to do that. I know 5 times 5 is 25. Times 5 is 125. So that's to the 3rd. And then we multiply by 5 one more time. So that's going to be 625. And let's be honest here, we can't simplify that any further, and that's end of the 4th. And that's about it. Okay, so now we truly have done every single example here for power rules. Okay, so I'm gonna go ahead and talk about kind of like those little nitty-gritty rules that we really don't always remember, but they're also equally as important. And really the only one we're missing is the negative exponent, which isn't mentioned up there, but it is just as important and as valuable. And really the negative exponent is just basically referring to a reciprocal. Okay, so negative exponent slash the reciprocal exponent. Again, it's just writing, telling you to do the reciprocal, but as an exponent. Sorry about that. And the way that it tells you is a negative. So if you have a negative exponent, you're just literally writing the reciprocal of that. You're taking the a to the n power and you're putting it in the denominator with a 1 as a placeholder. That's it. So for a, we're saying what this negative is saying reciprocal. Okay, so that means we're doing 1 over 4 to the 2. That's it. Really, 1 over 16. Okay, but even if you can't evaluate 1 over 4 to the 2, that's what the negative is telling you to do. B, it's telling you 10 to the negative 3rd power. Really, it's saying 1 over 10 to the 3rd power. It's saying reciprocal. And that works also for if if the negative is in the denominator. So if the exponent is negative and that whole term is in the denominator, and then you just bring it up to the numerator, because again, the negative means reciprocal. Okay, so for A, we have 1 over y to the negative fourth. That negative is saying take the reciprocal. So take all of this, bring it up to the top, and make that a positive. So that's y to the fourth. That's really all you're doing. Same thing here for B. We have 1 over 3 to the negative second power. Well, what's that saying? That's saying take what's in the denominator, bring it to the numerator, and make that exponent positive. 3 squared. That's it. Okay, and 3 squared is actually 9, because 3 times 3 is 9. But again, if you can evaluate, that's perfectly okay. All right, last set of examples here. Notice we are going to use the power rule by taking our exponents and raising everything to those exponents, okay, whether it's being multiplied or divided. So that's what we're going to do. Okay, now keep in mind, I'm going to assign that negative to that 2. You always have to assign a negative to one of the values, okay? So for A, we'll start with a simpler one. We're having a to the negative second power over 7 to the negative second power. Really all that's saying is, hey, just flip-flop those, make those exponents negative or positive. So the 7 goes on top, the 5 goes on the bottom, and then those becomes just squareds. Okay, another way that you could have done this is saying, hey, both of these exponents are actually negative. So to make those positive, just automatically flip these guys right away. So we could have flipped them before we even began. We could have just started straight from here. Okay. So let's do B, and I'm going to give myself just a tiny bit more space here. So for B, we could just change that negative. So I could say, okay, I know I'm going to have to flip these. So the y is going to go in the numerator. The negative 2x is going to go in the denominator. And now I can raise it to the third power instead of the negative third power. And then I just go ahead and raise every single little thing to the third power. So I have y to the third. Keep in mind, it's going to end up being a negative because it's an odd exponent. So I'm going to have 2 times 2, 4 times 2, 8, and then x to the third power. And really, that's it, guys. That's really all we're doing for this. Okay, so I'm going to go back to the top here. Okay, we've talked about everything. We've talked about the zero definition. The only thing that's not listed on here that I am going to list on here is the negative exponent property. And that was kind of a twofold thing. I'm going to add a little box here. Twofold thing here. So if I have a to the negative n, that's the same as saying 1 over a to the n. And then I'm going to have kind of like the converse. So a to the negative n as a fraction, that's the same thing as saying a to the positive n. Okay? So now we have absolutely done everything on here. Okay? Including all the different types of power properties. Okay, so I would definitely use this nice little table here that we've annotated. I'd screenshot it, put it in your notes, do something about it, because you are definitely going to use it. And this does require a lot of practice. Okay, all exponent rules takes time. Start with the simpler ones, start getting more and more complicated. You just watched 3 videos of this. Now it's time to really make sure you're practicing, because all of them are going to be used at any given moment. Okay, so go practice, and I will see you in the next video.